This is section 1.6, part 4. We are still solving and graphing inequalities, and in this part we are going to look at compound inequalities. So we're going to look at an example of an AND inequality and then an example of an OR inequality. Alright, so the first one up, letter C, is our compound inequality. It's our AND inequality, and I have a nice example here, which is -3 is less than or equal to 2x plus 5, which is less than 7. So, the AND inequality actually comprises or involves two separate inequalities. Alright, we have one inequality, which is -3 is less than or equal to 2x plus 5. And the second inequality is 2x plus 5 is less than 7. Those are two separate inequalities combined together to make a compound inequality. Alright, and when we have an AND inequality, both of these inequalities must be true for this to work. Both have to be true. So, let's try and solve this. Alright, so since 2x plus 5 is part of both inequalities, alright, we're going to always start in the middle, alright, because that's typically where our variable is going to be. Alright, so we want to isolate, I'll get the highlighter, we want to isolate x. We want to get x on its own. Alright, and so, in this case, we're going to start with our positive 5. Alright, we want to cancel this 5. Alright, so I'm going to subtract 5 from the middle portion, and I'm also going to subtract 5 from the 7. And remember, that's one inequality. But 2x plus 5 is part of two inequalities, so I also need to subtract 5 from that other side as well. So when you have an AND inequality, you're going to subtract that number in 3 locations. So -3 minus 5 is -8, is less than or equal to 5 minus 5 is 0, so that cancels, so I'm just left with 2x, which is less than 7 minus 5 gives me 2. Next, I want to detach this 2 from the x, so I'm going to divide by 2. And I need to do it to both sides, so I'm going to divide by 2 here, as well as here. So we see -8 divided by 2 gives us -4, which is less than or equal to x, because 2 divided by 2 is 1, so those cancel. And then is less than 1. So our solution looks like it's -4 is less than or equal to x, which is less than 1. Alright, and remember, AND is to shade in. You always shade in when you have an AND inequality. So that's going to be helpful when we graph. So I want to start with at -4, and I'm going to end at 1. So I've got -4, -3, -2, -1, 0, 1. So -4 is less than or equal to x, so what kind of circle do I have at -4? A closed circle. And I also have a open circle at +1, because x is also less than 1. And we know with the AND inequalities we're going to shade in. And we're done. This is our solution. Now we want to make sure we've done it correctly, so we can check really quickly. Any number that is in the shaded portion. So I'll pick 0, and I'm going to plug in 0 for x. So I've got -4 is less than 0, which is less than 1. So is -4 less than or equal to 0? Yes. Is 0 less than 1? Yes. Both of them are true, so we know the problem is done correctly. Next, we're going to go on to letter D, which is also a compound inequality. And we're going to look at our OR inequality. So if you were to shade in with AND, or remember we're going to shade out. So that'll help us when we get to the graphing portion of the problem. So what's the problem? You're probably asking yourself. Well, let's look at nope, I'm sorry. 3x plus 1 is less than or equal to 10, or 19 is less than 4x minus 1. So with the OR inequality, we actually have two separate inequalities. And so we're going to find a value for x, maybe 2. Sometimes you're going to see that x can be two different values. And that value of x, when you plug it in, all right, it only needs to be true for one of the two inequalities, not both. Remember, and it has to be true for both, or it only needs to be true for one or the other. All right, so let's get to solving. All right, let's look at 3x plus 10 is less, or 3x plus 1 is less than or equal to 10. I want to isolate that variable. I want to isolate x. All right, so I'm going to subtract 1 from both sides. 1 minus 1 is 0, so I'm left with 3x on the left-hand side of the inequality. 10 minus 1 is 9. Next, I'm going to divide both sides by 3. 3 divided by 3 is 1, so those cancel. And I have x is less than or equal to 3. I'm going to rewrite this x. Now I'm going to solve the next inequality. 19 is less than 4x minus 1. So I'm going to add a 1 to both sides. 19 plus 1 is 20. So I have 20 is less than 4x, because negative 1 plus 1 is 0. Next, divide both sides by 4, and we see x is on the right-hand side of the inequality now, and 20 divided by 4 is 5. So we see 5 is less than x, or x is greater than 5. So the last step here is to graph them. So we've got 2, 3, 4, 5, 6. So I've got x is less than or equal to 3. So I've got a closed circle here. 5 is less than x, open circle here. We know the OR shades out. And we'll kind of look at the logic of this in a second. But this is a nice little shortcut. And in or out. So let's think about it. All right. We've got x is less than or equal to 3. Variables on the left-hand side, so we can listen to that little arrow. The arrow is telling us to point left, so we shaded that way. Is 2 less than or equal to 3? Yes. Here we have 5 is less than x. Well, the variables on the right-hand side, so if you remember in the previous videos, I think it was 2 videos ago, I told you if the variable's on the right-hand side of the equation, you have to do the opposite of what this little arrow is telling us to do. Right? So the arrow is telling us to shade left, but I know I have to do the opposite of that because the variable's on the right-hand side of that inequality, so I'm actually going to shade right. And if we plugged in 6, is 5 less than 6? Yes. So we know it's true. All right, so here is our answer.